like My
He had a lot of older movies too.
Yeah.
I mean, older animes. One is Heidi.
Heidi.
Yeah, this is like really, really way in the past before he got famous. So he made a series of, Heidi, the story of Heidi, the Alpine, little girl, and he turned it into a animated series, and it's really quite nice.
Interesting.
So if you look up Miyazaki and Heidi, you probably will find it. I think the title was not Heidi; they had to change it to something else. All right, so let's go ahead and get started because you guys are getting your first programming assignment. But it's not too bad, okay? Because if you remember what we did on Tuesday, this one is, I would say it resembles quite a bit of that homework assignment, except it's not identical. It has a little bit of adjustments to it. I'm pretty sure most of you can just download my program on Tuesday, which is online right now. Okay, has been online since Tuesday.
Yeah.
Open up Scratch, look at the requirement of your homework assignment. Not even to start from scratch, no pun intended, because we are using Scratch. And just modify certain parts of the program and get it, up and running. So let's go ahead and take a look at the homework assignment first, and then we'll kind of go back and, continue with our current, topics, because there are more stuff to cover in terms of programming. So I sent you guys all an email message. Anything that I post to the news forum, you will also receive as an email message, and that's why most of you probably have the email message already. And that's down here. There are many ways to find your homework assignment, and the homework assignment is called Scratch 1. Okay, this is the first time you have to turn in something because all the previous quote-unquote homework assignments are more like quizzes, except you have got an infinite or unlimited attempt. So this one uses Scratch. You have to download and install Scratch from MIT if you have not done so already. We have been kind of playing with Scratch for several weeks now, so I'm hoping most people have it already downloaded, installed, and play with it a little bit already at this point. But if you have not, it's no big deal. Here's a link to Scratch. So just click that link, go to the Scratch website and download the software and install it. And I want you to write a program that will do the following. This is a step that is missing in your homework assignment. Use a random operator to pick a number between 1 and 100, and we'll call this quote-unquote the solution. In other words, we're turning into a number guessing game. Okay, we just want Scratch to come up with a number, and we as humans, as players, will try to guess what that number is. All right. So then Scratch will have to ask the user or the player for a number. Okay, what do you think that number is? And then you have to type in 45, whatever number you want to use. If your guess is greater than the solution, the sprite has to indicate that using either say or think. But you have to use, you have to indicate the guess is greater than the solution. It's not just not equal to, but you also have to indicate it is greater than and not less than. Because if the guess is less than the solution, you also want to indicate that as well, using also either say or think. Then you want to go back to step 2 if the guess does not equal to the solution. In other words, you go back to step 2 to ask the user for another guess and then go through this process again. If the guess does match the solution, you want to indicate that, oh, you just got the number, it is the correct answer, and then you can end the program's execution. That's it. Does it resemble the program that I wrote on Tuesday? In some ways.
Yeah.
In a lot of ways.
Yeah.
You can even keep the structure of the program, except to make some changes, minor changes to that program, and that's it. And you are explicitly allowed to download that program and use it as a starting point if you want to.
It's good notes too. It's good notes too.
Good notes, plus there's a video to go with it, so if you don't understand what a loop is and what a conditional statement is, you can go through the lecture again, in video form and just kind of revisit some of those concepts and ideas. All right, so that's your homework assignment. You have 1 week to work on it, which I think should be enough time. Question? No? Okay. So that's your homework. And for those of you, who are, yep, go ahead.
Roshi,
Roll sheet. Yes, it's right here. Thank you.
Can we do roll sheet advice?
I don't remember whether we did it or not. I think we did.
Right, put the program and stuff like that. I'm like, I should have put
Okay.
it on the stage.
So here's just a quick question. I know most of you are thinking, well, you know, if I have to debug this program and the number is from 1 to 100, you know, that's, you know, really hard to test the program, isn't it? Well, there are two ways to make this program easier to debug. When you are testing it, instead of going from 1 to 100, use 1 to 10 instead, okay? Or use a fixed number. So you can test the rest of the program, knowing what the solution is, just to make sure that your program behaves correctly and you give it a particular yes. And then, you know, at the not last minute, but you know, before you turn it in, you'll change the number, the fixed number, to a random number from 1 to 100. Then you can test the program again, and you'll be done with it. The other thing is you can also use what we call quote-unquote binary search. In other words, when you try to guess a number from 1 to 100, you don't start with 1 and then proceed to 2, proceed to 3, and so on. You start at 50. In other words, you pick the middle number out of the entire range. The program is supposed to tell you whether your guess is greater than or less than, you know, the actual solution. So if it is less than, that means, you know, the number is from 1 to 49. You pick another one number from the middle of that, which is 25. In other words, every time you get, no, this is not the right answer, your guess is greater than or less than, you reduce the range of numbers by half. So how many times do you divide 100 by 2 before it becomes a number that is less than 1? The answer is 7 times. 7, because 2 to the power of 7 is 128, which is greater than 100. So at the most, you only need 7 guesses to get to the right number, even though it's from 1 to 100. Okay? So there are different ways to speed up, you know, the debugging of the program. It's up to you to decide, you know, how you want to do it. And this is just the bare minimum to get full score for the homework assignment. If you are inclined to make it more fun, you know, I cannot give you any extra credit for the fun part, but some of you may decide, hey, I want to do it this way, you know, add more music to it, you know, or use a scale, you know, tip the scale, you know, to indicate which one is greater. You know, that's entirely up to you guys to decide. All right. So are there any questions about everything that we have talked about so far and the homework assignment? No questions? Yep, go ahead.
What about the exam?
What about the exam?
You said you're going to talk about it. What do you think?
Well, I look at the exam and the distribution of the score is really uneven. You know, it's a trimodal distribution. So we have, you know, a bunch of people getting really high scores, a bunch of people getting in the middle, and then a bunch of people getting the low scores without the continuity that I usually see with a normal curve. So I think I'll give you guys, you know, an extra credit, you know, assignment or something like that to make up for some of the points.
Yeah, some of the short answer problems, if you misspell it slightly, like one
right,
letter.
you know, and that's what, you know, that's what he mentioned,
that's
you know.
not
I mean,
that good.
but I can change the solution to accept additional alternatives. So, you know, we can go over that, and, you know, I can fix it once and then I can regrade the whole thing so everybody can benefit from the additional solutions. Yep. So we'll, you know, definitely let me know, you know, if you think that they graded you wrong because, you know, it's the same word except I misspelled it, or, you know, I used the plural version of it. Yep.
Future tests that have short answers, could you just simply, like, give us like a PDF or something that just has a whole bunch of listed terms that could possibly be the answer that we should pick from?
It could be severely larger than the actual, you know, options. Just have that way we have correct spelling.
Like separate from the test, so it can encompass a whole bunch of questions.
Yeah, I could do that, but I have to do it manually because there's no way to do it automated, automated way. So I have to go through the questions and look at all the keys and then extract all the keys out and, you know, turn it into a list. So that might take a little bit of time.
Yeah.
Or I can, you know, try to understand how the database is organized. You know, spend even more time to understand how the database is organized. Write a script to extract all the words and then, you know, and make the list. I actually will do it that way rather than the first way, because the second way, even though it takes more time, is more fun. Yeah, the first one is more like, you know, chewing styrofoam. It's like it's not nutritional, it's not poisonous, and has no taste. I think food has to fit at least one of the requirements.
It is a nice requirement.
It can be a little bit toxic or unhealthy, but it has to be tasty, right?
Yeah. Like McDonald's.
No.
Some McDonald's is kind of good.
That stuff's toxic, bro.
Yeah, McDonald's is not tasty. Not to me. Some people like it. I like the apple pie. That's it.
Yeah. It's still bad for you though. But it tastes good.
It tastes good, exactly. So what we'll do today is to continue with the programming topic. And what we will do is to continue with the program that we talked about on the other day. Remember, we had a program that would ask people to input 2 numbers, and it would keep asking people to input 2 numbers until they are exactly the same. So you have to change that program, or you can use that program as a starting point. What I'll do today is to change that program a little bit so it becomes a password issue, okay? Now, it's a password issue now so that I want to implement this logic. You know how you use when you do online banking and you type in your ID and then your password? If you fail to log in several times in a row from the same IP address, the bank, a good bank system will basically just disable your account from online access. Give you a message on the screen and say, okay, you have tried to log in for 5 times consecutively or within an hour, and it failed to log in. So the bank system will suspect somebody's trying to hack into your account and disable the account and say you have to come into a branch office or call us to reactivate your account. Okay, so we want to kind of figure out how to do that logic. Okay, which is how do you say, okay, if someone tried to log in consecutively for X many times, then it's time to disable the account. Okay, so that's what we'll do today. And I'm thinking I should start the program from scratch because otherwise it will look very similar, or portions of it will look very similar to your homework assignment, which defeats the whole purpose of the homework assignment. All right, so let's go to education and get Scratch started again. All right, so what we'll do is, I'm not going to do a whole lot of error checking this time, so I will just go ahead and assume the input is correct. So we'll go ahead and go to control and have the entire program to start with a green flag. And we'll probably go ahead and change this later, but for the now we'll go ahead and start when the green flag is clicked. And immediately go to looks. Well, let's go to variables. And we'll first make a variable to represent the actual password. Okay? So this is the actual password. And what we want to do is to set the actual password to something to begin with. It's for me this is just a test program, so I can just set it to a particular setting. And of all the movies, and of all the passwords, there are several that stood out in my mind, and one is No More Secrets. Which movie did it come from?
That's a good question.
No More Secrets.
Which way did it come from?
Many of you are probably too young to have watched that movie, Sneakers.
Oh, I've heard of it. I don't think I've seen it. Was it
I
Robert
really hate to
Redford?
give out wrong information, so I want to double check on that too. Sneakers, password.
Robert Redford movie?
Yep. No More Secrets.
Sneakers.
If you just type
Yep,
in sneakers, you
that's
should
it.
find
All right.
River Phoenix.
It's a quotable quote from Sneakers. See, right here. Carl, so it's a code breaker. No, it's the code breaker. No more secrets. Da 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 da. You gotta watch that movie if you're into hacking or computer security and that sort of thing. It's a really good movie. It's not as bloody as some of the other spy type of movies, but it's very tense. There's always something going on, and it's a puzzle to solve too.
something every
All right, so I'm setting the actual password to No More Secrets. I only have to do that once because that's the actual password. And then from here on, I want to implement the logic that I want to deal with, which is, okay, I want to lock out the account after so many consecutive failed logins. There are several ways to run this program. Because the variables actually retain their value after you run it each time. So what we can do is to say, okay, each login attempt is one click of the green flag, or we can also use another key to trigger the execution of each login attempt. So we'll probably do it the second way. So the green flag is all it's doing is to trigger the initialization of the program, which is the actual password set to no more secrets. Okay, yep, go ahead.
Is it going to be case sensitive?
It is not case sensitive.
So it can be just no more secrets.
It can be all lowercase, all uppercase.
Okay.
Yeah. But I just use the Unix convention, which is when you have multiple words in a single word as a variable name or password, you capitalize the first letter of each word. That's the kind of Unix standard, but it's a very well-known standard for naming variables and other things. All right, so we'll probably just put an and to it for now. So we'll go to the end here, stop script, put it here, because I always like my scripts to have a beginning and also an end. And what we'll do now is, we'll say, but we want to trigger the actual logic to ask someone for a password and then check it and see whether the account, whether we should log in or lock out the account. So what we'll do is we'll write a second script doing that. And for now, we don't quite know how to get that script started, so I'll just go ahead and write the content of that script, because you can always click the script itself to start the script, so you don't need any of the triggering mechanism. So we go to looks, and then we ask the question. Oh, that's a sentence, excuse me. So we'll say ask, what is the password? And wait, okay? And after this step, when you look at answer, which is this bubble here, answer will become the actual input. So we have to do something about the input. What do you think we should do about the input, the answer? We should probably check it, right, to see whether it matches the actual password or not. Well, just checking it doesn't really do a whole lot of good. What do you think we should do next?
Put in the wrong password? Put in the wrong password?
If I put in the wrong password, it has to do something. If I put in the right password, it has to do something else, right? So we have to use a conditional statement, also called a branch or if statement. Very good. So now we have identified that we need an if statement. So I go to the control tab, get out my if else. Now remember, sometimes we kind of think that, well, I think we can get away with just the if, but I always put in an if else, so that it forces me to think about, is there something else to do when the condition is not true? In this case, definitely. Okay, depending on whether the password matches or not, the two actions are completely different. So we'll go ahead and perform the checking first. So we have to go to operator because we are matching something, so we have to use the equality check operator. On one side, we have the answer from the previous question, which is the answer to what is the password. And then the other side has the variable that I call the actual password. So when you look at the green hexagon, it is what we call a Boolean expression, or something that returns either true or false. Okay, that's the Boolean expression name is a kind of formal name, but it is something that is either true or not. It's either true, the answer does equal to the actual password, or it is false, the answer does not equal to the actual password. And for now, what we'll do is we will just go to looks, and we'll just say something when the password matches, say something else when the password does not match, and we'll test the logic and see whether that works or not. So if it does match, then we can say sign in successful. Okay, I'm just trying to keep it simple here. And if it does not match, then we'll say sign in unsuccessful. If this is an actual program, Do you think it's a good idea to tell the user, you know what, the username is right, but the password is wrong. Try again. Would that be a good idea? No, no. What should you do instead? Just say, authentication failed.
Yeah.
Okay? Without telling the end user whether it is the username that's wrong to begin with, or whether the username is right and the password is wrong. Because if you indicate that the username is right but the password is wrong, a potential hacker will now say, okay, I got at least one thing right, I can keep guessing the other part.
Yeah.
But if you don't give any indication, a potential hacker will have to think, okay, did I even get the username right? Because if the username is not right, doesn't match any existing entries, then you can guess the password for all eternity, and it simply won't work.
Some systems still kind of do that by saying that username does not exist in our system. But then when you put in the username and the password, it'll say either username or password is incorrect, even though they already said, oh, that username doesn't exist in our system. So they indirectly tell you that's a correct username.
That's not a very good idea, especially with online banking. For other things, maybe it's not as important. Like if you just want to deal with a forum, that deals with, like, let's say, quilting, right? If you can log in as somebody else, the worst you can do is to offend all the other quilters in the world.
But still,
Yeah, they all got cisc310, so they're all dangerous.
Yeah.
they still say it's incorrect, so the hacker still has to guess both username and password. Then
Right.
they say the username is correct.
But you don't want to indicate the username is correct,
Yeah. But
Yeah.
they never do.
Some systems do, as he said, and I have seen it too. Some systems, obviously, it's written by a programmer and not, from someone who has a perspective on security. Because programmers, want to provide information, right?
Yeah.
So if it is just if it's just the password that is not correct, I would just tell you that your password is not correct, to reflect the actual condition that triggered the message. But sometimes, it's saying less is better, and in this case, it's definitely that case. All right, so we can test the program already. The first thing I have to do is to set the actual password to no more secrets, because you can see that the initial value of any variable starts with 0. So we'll just run the script once, and now it is changed to no more secrets. And now I will trigger the execution of the second piece of code. Now I don't really have a start block associated with it, but I can still get it started by double-clicking it. See, when I double-click on a block of code, even though it has no start block whatsoever, I can still trigger the execution of just that block of code, which is great for debugging, because you can now pull a chunk of code out of the entire program, or duplicate out of it and out of an existing program, and only test that portion of the program. So I'll just give it something that is not correct. So I'll say what password, and it says login is unsuccessful, which is what it's supposed to do. And once again, I'll run this code again, and this time give it the right password, no more secrets. And it tells me that the sign in is successful, which is good, okay? The program works up to this point. Next, I want to implement this program so that it kind of keeps track of how many times I have logged in unsuccessfully, okay? I don't really need to keep track of how many times I have logged in successfully. I just have to keep track of how many times I have logged in unsuccessfully, but also consecutively. In other words, if I log in successfully once, and then next time I had a typo, you log in successfully, but then I realize, oh, okay, I had a typo and log in successfully. I don't want to lock out the account if I just log in unsuccessfully over a whole period of 1 month and interleaved by a lot of successful logins. Okay, because if I did that, you can say that it doesn't make the make the system any less secure, but customer service would not like it. Because a lot of people will make little typos once in a while, and if they fail to log in 3 times, no matter whether it's successive or not, customer service will have to deal with a lot of calls of a lot of unhappy customers. So that's why we want to only keep track of consecutive or consecutive failed logins, not interleaved by successful logins. What do you think we should do? Do you think we need another variable? We don't have enough variables to keep track of the information that we need to.
Repeat like certain amount of times.
repeat a certain amount of times, but each time people log in. Oh, okay, I see what you mean. So you basically set up a loop so that every time that person tries to log in, you don't get out of the loop until it either matches or the number of times has reached.
Yeah.
That's not a bad idea, except it doesn't really work well with web scripts, because every time you try to log in with a website, it actually starts the execution of a script from the beginning, from the very beginning. So if you try to set up a loop inside the script, it doesn't really generate the page correctly. It's weird, but it doesn't work that way with an actual script. So what we'll do is we'll mirror that particular process and just say that we will trigger this logic every time someone tries to log in. So we're not going to use a loop in this case. But what you said is good already, because in order to set up a loop like that, you have to keep track of a counter, right? How many times have we gone through this loop? So in this case, we are not using a loop, but we still need a counter. So we'll go to variables and make a new variable, and we'll call this new variable. Now, if you want to, I want to make this kind of more self-documenting, so I'm going to call it number of failed logins. Well, since I can use a space character here, so I can say num failed login, okay, which is just a number. When I initialize everything, now I should also initialize that particular variable. How do you think I should set it?
0.
Set it to 0, exactly, because when you first create a user account, that user has not even tried to log in yet, and as a result, the number of failed logins should be 0. Very good. And then what should we do about that number? Is there a place where I need to do something about that number?
So we should increase it by 1 when we go after else.
Yeah.
Okay, all right, that makes sense to me. Change that by 1 when the answer does not match the actual password. So we'll go ahead and increment num failed again. Num failed login by 1 when the login has failed. Now I know this program is not complete at this point, but I'll still go ahead and run the program, just so that I have a better feel of, okay, how much have we accomplished? And, is it working already? Is it working the way it's supposed to? If it is not, how is it not working correctly, and how we can modify the program? In other words, I'm not trying to write the entire program in one shot. I'm just adding some details one at a time, so I can debug the program also one step at a time. All right, so we'll go ahead and click the green flag to reinitialize both variables. Even though they are starting with the correct values already, it is always a good idea to initialize your variables. If you reinitialize something unnecessarily, which means it is still correct, it takes up like a really small amount of time in terms of the execution of a program, but at the same time you're ensuring that the variables start with the correct value. So I would definitely do that, even though sometimes we can say, well, but we know that this number starts with a 0. But you know what? After we run this program a few times testing it, it's not going to be 0 anymore. All right, so we'll go ahead and run the second script by double-clicking it, and we'll go ahead and test the first part first, which is what happens when the password is correct. So we say no more secrets, and it says login is successful. It does not do anything to num failed login, which is correct. So it worked okay. And we give it some wrong passwords. Okay, so wrong password, login unsuccessful, and we can see the counter is counting up by 1. That's good. That's what it's supposed to do. And then we try again, wrong password. It increments to 2 after this. Very good. And then we try again. So we try, funny password. And it increments to 3. So everything is working up to this point, right? So let me try to fail to log in one more time, and we say cannot tell you that's the password, and obviously that would increment it to 4. But the program is not doing what it's supposed to, because it should have locked up the account when the counter gets up to 3. Okay? But that's okay, because I have not integrated that logic into this program yet. All we can do right now is to say, num failed login seems to be updated correctly. But that's really not the case either, because watch this. What if I log in again, or try to log in again, and this time I give it the right password? No more secrets. It doesn't change, it does not reset num failed login, which is bad, because it is supposed to reset it, because num failed login is supposed to log number of consecutive failed login, not just the number of failed logins. So I have a choice now. I really should change the name of the variable.
Set it to 0.
We should reset it to 0. When after a successful login, we have to set it back to 0. Very good.
So but when you successfully type in the right one, you already logged in.
Right.
But it's to reset the counter.
But you have to reset the counter.
That way you don't have 2 wrong ones. And then 3 years later, you finally make a mistake.
Oh, you mean when I go back to try to log in, like next day?
Right.
Yeah. You make a mistake.
Yeah. So after a successful login, we have to set num failed login back to 0, because it's supposed to log the number of consecutive failed login, which also means the name of the variable could be improved. Okay, it should have said number of consecutive failed login and not just number of failed login. But that will make the name kind of really long.
We get the idea.
Okay. And I'm not even sure it gives you, it doesn't have that option to change the name of a variable once it is created. So it's kind of, difficult to change it now. And the same thing applies when you write programs too. When you if you want to change the name of variables after you write your program, a lot of times you have to be really careful, because you have to make sure the new name does not match any existing variables. Because if it does, then you have a big problem on your hand. All right, so let's go ahead and run this program again. Just run this script here, and this time we give it the correct login, the correct password, no more secrets. And it says login successful, and reset num failed login back to 0. That's the way it's supposed to do it. We only have one more thing to do. That one more thing to do is to say, if num failed login is greater than or equal to 3 already, don't even ask whether to log in or not. But that's okay, because this block of code can be inside a conditional statement, right? So what we will do is to write a conditional statement, or drag and drop a conditional statement, initially empty, and we just want to focus on the condition. Okay, the condition basically determines, should I even ask the user to log in, or should I just say, oh, okay, your account is now locked up, you have to call the bank to reset the account. So that's what I need to decide. What would be the condition that goes into this hexagon here?
If the number of failed logins is equal to 3 or greater than 2.
Okay. So there are several ways to express the same thing. I can say if the number of failed login is less than 3. Yeah, if it's less than 3, then we can do it. So in this case, I can put a 3 here. Now here's another programming tip. When you write an actual program, in your next class, the C, C++ class, or Visual Basic, or any classes like that, in an expression, if you put in, numbers like 3, basically they're called constants, or literal numbers, okay, because they spell out the actual value. You have to think about it and say, should I actually put that number into a variable first, and then use the variable where this 3 is supposed to go? The reason why you want to think that way is, what if your boss tells you and say, you know what, I want the number of consecutive failed login to trigger the logout to be 5. And then the next day, he or she comes back and say, I think 5 is too many. I want to change it back to 4. Okay. If you make this a 3 and you have other parts of your program that depends on this number, then you have to modify all those 3s to 4s to 5s and so on and so forth. But if you use a variable to indicate the number of consecutive failed login to trigger the logic, Then you only have to change one, particular statement to initialize that value, and you're all set. So it makes more sense not to use a 3 here. Instead, we go to variables. Now this one is not exactly a variable because once we set the value, it doesn't change anymore, but we still call that a variable. So we'll call this one maximum failed login max num. None? No, num. Okay, so we'll create a new variable name called maximum number of failed login, and also have a statement to initialize it. And we can just set it to 3 for now.
Wrong one.
Oh, maximum.
Defeat all purpose. You already lost.
Yep.
But you already lose.
You already got locked out.
Yeah. But
So now instead of using a 3 here, I go to variables and then go pick out maximum number of failed login and stick it here. So from here on, I can just use the name, the variable name num, max num failed login instead of a constant 3. And I think from the perspective of readability, of self-documenting feature, this is better too. When you read the program, it actually makes more sense because it tells you what the 3 actually means, when you read the program. All right, so we're almost done here. The question now is, oh, no, that's not. Okay. If the number of failed login or consecutive login, the number of consecutive failed login is less than the limit, what do I do?
ask. Well,
Do the whole block here, right? That's easy. If it is greater than or equal to, what should I do? Well, we can just give the user a message and say, your account is now locked out.
Max attempts reached. No more logins acceptable or something like that.
Or you can just ask them to call.
Say hello.
Say hello, yes.
What is this week?
What is that?
You literally just keep saying hello.
Whatever you do, don't call your customers newbie, okay?
Oh, that's new. I'm
Noob.
online, so you know.
It's N00B2, it's not NOOB. Okay, so when the correct message here is to say give it the error message. Okay, this is error number. Give it some number here. Call a branch to reset your account, and then give the a phone number too. So you can make up a number. 916. Yeah, it doesn't matter what it is. So I just made up a number here. In other words, you want to save your customers the trouble of having to look up the phone book or the statement, and instead they'll give it a number.
Look at B. B.
E.
You put the parentheses right there.
I thought I did, but it didn't show. Oh, okay, I put it at the wrong spot. All right, that should do it. Yep, there we go. Excellent. So now we can go ahead and test the program again. So we trigger the logic, and it sets that message right away because you can. Okay, it's not supposed to do that. If number of failed login is, oh, you know what? I forgot to do one thing. I forgot to run the green flag thing to reinitialize everything. So I've got to do that first, reinitialize everything so that max num failed login is now 3 instead of 0. Then we can use this logic. Ask me for the password, wrong password, wrong password, wrong password. And one more time, it says, call the number. It doesn't even let me enter a password anymore. Are we doing okay so far with this logic? Okay. So the next question is, how do we trigger this logic? In other words, what if I want this program so it has 2 ways to start? One is when the green flag is clicked, it will do the initialization and then trigger the execution of this entire block of code so that I don't have to click the green flag and then double click this block of code. Plus, I also want to trigger this, the execution of this code when I click the sprite itself. So that's the question. I want two ways to start the exact same script here. The obvious but not so good answer is to have another block, with the beginning and the end, and then right-click duplicate, right-click on the block of code, and then select duplicate, and then have two blocks of code like that in two different places. Let me just illustrate what I meant by that. It's not a really good approach, but that's what most people would do. So I would say when sprite 1 is clicked, okay, and put the end to that script 2, and I would just have to duplicate this. Okay, duplicate. One copy goes here. It's just hard to read. Okay, it's all right. It's under control. And now I have two blocks of code, just like that. So now I can double click. I can click the green flag. It will execute that code and ask me for a password. Or I can just click the sprite itself, and it will just ask me for the password. So that works. But this approach, copying and pasting, has a problem. What if the original logic was one that I just cloned or duplicated? What if it had a problem? What if I want to add some features to it? I now have to do it to two places. Not to mention that the program actually gets bigger too. Okay, the actual executable also becomes bigger. So this is not a very scalable approach. Okay, it works, but it's not really the best way to do it. The best way to do it, given the limitations of Scratch, is to do something kind of more along the line of this. Okay, so we can now toss away one copy of the code and keep the other one. But essentially what I need is now two ways to trigger the execution of this block of code. In Scratch, there's one way to do it. Okay, it's not called a procedure or a function or a subroutine, which is what a typical programming language would use. It's called broadcast and receive. So what we want to do is to say, when I receive a particular message, okay, so I would name that message now. The message is to say
Sign in.
prompt password, okay, or sign in, okay, very good. Authenticate, sign in, okay, sign in is good. When I receive sign in as a message, go ahead and do this block of code, and when it's done, stop this particular script. Now at the other two places, I can now use broadcast and wait. So I can say broadcast, sign in, and wait, and do the same thing over here. Broadcast and wait. And what this does, what broadcast blah 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 and wait does is it will broadcast a message. And it has to be one of the messages that can be received by other blocks of code. And it will wait until that block of code is done. In other words, in this particular case, if I click sprite 1, it will start this block here. And then immediately it will get to the second block. It will broadcast sign in to every script and every sprite. Okay, this is universal. Since I only have one here, it would simply execute this block of code. This block of code will do exactly what it always does. Okay, and when it's done, it will go back to this point so that this particular script will stop its own execution. But if I need any additional code, I can put it before stop script. Is that okay so far? All right, so let's test it. Click the green flag again. It reinitializes everything, and it still asks me for the password. And you can now see that two portions are now highlighted in the script area because they're both active. One is waiting for the other one to finish, and then the other one is waiting for you to type in something. So let's go ahead and give it the wrong password. And one of the favorite password that you can kind of imagine is what password. So when someone asks you what is your password, you just say what password. Okay, so what password is the wrong password? We can see the number of failed in, has incremented by 1, which is correct. Now we can try the other way. Click the sprite itself, and guess what? It triggers the same code to execute. In other words, with this approach, I can keep only one copy of the actual sign-in logic and not have to duplicate it, even though I might want to trigger that logic from different places. And the rest of the program, will still do the same thing. I can, just give it 3 failed logins, and it should lock up my account after that. And then one more time, it locks out my account and asks me to call a branch to reset the account. Yep.
I have a question. So why do you have to click every time? Shouldn't it ask you automatically when it's the wrong answer? Why is it that? Since it's in the
You're correct. It should ask you like right away, but I'm assuming this is actually inside a web script. Inside a web script, there's no such thing as a loop to go back and ask the same thing again. In other words, in a web script, if someone inputs the wrong information, you actually have to tell the script which other script has to run after this one is done. It's a little bit awkward, because every time you submit something, it starts the execution of the script from the beginning. I can illustrate it with an actual sign-in session here. Now, since I don't have any account with Chase, it's perfectly safe for me to try to log into Chase.
Yeah,
So what I want to illustrate is when you type in your username, blah blah blah, and password, blah blah blah. Okay, when you click login to accounts, it's starting the execution of the script from the very beginning. And you may not, now when I do this, this is not even a loop. This is actually another web page running from the beginning. So it's not a loop from the perspective of the web script, even though in our mind, hey, this seems to be a loop, but it's actually not a loop from the perspective of the script. Okay. How many people are interested in web scripting, like writing web pages or scripts that can do something like this? Okay. How many people think it might be able to make some money? You might be able to make money knowing how to do web scripting. It's important, okay? And can anyone guess, what is the #1 problem of security, computer security? Go ahead.
Too many security holes in browsers. So companies now, instead of waiting for the browser to actually patch the hole, they do it themselves by giving their customer more security by going through these web scripts. And patches it and make sure that no one goes in. It kind of creates like a tunnel. That's why they always go to HTTPS. It's the security tunnel that they make sure that the browser is no longer the problem. It's their web script that make sure it's protected in the customer.
The web script, the web script itself is actually the source of the problem. And this is, I'm taking a little digression here, but it does relate to programming and also careers in programming too. Can anyone remember back in 1999, 2000 or so, what is significant about 1999 other than it's a millennium change?
Y2K.
Yeah, other than that, other than the Y2K thing, why was it a good time or bad time to have a degree in computer science?
It wasn't a good year. It wasn't really that good.
It was a good year.
It was good for entrepreneurs to think about the future of it, but
Right. But
people weren't really hiring for it.
No,
because
that's
everyone was
that's
scared.
you're talking about the dot bust. The dot bust, started in 2000, in late 2000 to maybe 2003 or so. That's the bust of the boom. The boom peaked out in 1999 to 2000. Okay, you may not remember it, but it was a big boom. If you are here in Sacramento, you may not feel anything. But if you were in the Bay Area, living in the Bay Area, these high-tech startup companies were pushing out all the conventional businesses out of their buildings. Because the landlords of these commercial buildings, they all want to make more money, right? And all of these startup companies have tons of money from venture capitalists. and they're all saying, I need this space, for my, new setup, my new company, and I'm willing to pay, twice the rent of that guy who's paying it, to run a grocery store. Okay, so all these conventional stores and all the conventional shops got pushed out, from the Bay Area because they could no longer afford the rent. Okay, and that's how much money was pumped into the Bay Area. They soaked up every single developer or programmer or software engineer that was available in the market. In other words, if you go to Monster or any other type of job-seeking websites, and you say that I have X number of years, X can be 1, 2, and so on, companies will just pick you up right that, just like that. They ran out of people like that, so they had to go to graduate schools. They have a few universities in the Bay Area. They have Berkeley, you have San Jose State, San Francisco State, and Stanford, and a few other schools. And they quickly ran out of graduate students too, so they had to go to Davis and recruit graduate students and also undergraduate students from Davis. The pay was well enough that some of the students just suspended their academic work for a year or half a year just so that they can make the money during that time. It was really good. And then they ran out of graduate students and undergraduate students from universities, and then they had to go to high schools. They had to go to high schools and ask students in the high school and say, okay, who has learned anything about web scripting? I might know something, because I'm still reading this book, PHP scripting for dummies. You're hired. You're hired. And when they say you're hired, they're not paying you peanuts to scrub the toilet, okay? They are paying you big bucks, okay? Pretty big bucks, and the first thing they ask you, especially if you already have established that you are, capable as a programmer, they will give you anything, okay? You can pick out, furniture, expensive, desk chairs and whatnot from a catalog, and they will order that overnight, so next day you have it. They will cater for your lunch and dinner, so you never have to leave the office. They will arrange, 24-hour fitness, companies and whatnot to have a deal with them, so you don't even have to go home to shower. You can just go to 24-hour fitness across the street and then come back to work.
Have you ever been offered something like this?
I was working part-time, in the summer, and my pay was about $4,000 a month, which was good money. As a part-time job, it was good money. I did not have to be there in the Bay Area. I was working basically online for the most part, but I do have to go to their weekly meetings, which was always on Thursdays in the evening, and that was the worst part of the deal, because I had to start driving from Sacramento to Palo Alto at about 4:30, and it typically took 3 hours and a half to get to Palo Alto to get to the meeting. So by 7 o'clock, so I would get to the meeting, sometimes late, and the meeting would last about an hour. and then followed by an hour and a half of Indian dinner, and then another 2 hours and a half, to drive back to Sacramento. So that was the worst part of the deal. But other than that, it was good money. It was really good money, especially for graduate students and undergraduate students. They were paid, $5,000 a month. Yeah, it was good money. And as I said, they would give you everything. They would have masseur, to help do the massage thing on site. Okay, so you don't have to leave your desk. You can keep coding when you're getting massage, right? Yeah, it was good money. But why do you think I mentioned that? What do you think that part has to do with what we just mentioned, with web scripting and security? Remember those high school students who were still reading, PHP programming for dummies?
They never really got their education.
Right, but their code got put into the products. That was the problem. Okay, they were not playing in a sandbox and they were like, yeah, nothing happens if security is a problem. They were actually putting out that code and putting into actual products. So after that, for a very long amount of time, even now, some of the websites have these copied and pasted code from PHP programming for dummies that was not secure, and and websites are still getting hacked because of that. So the number one security threat is not really the servers. It's not like oh, you're running a Microsoft server is not secure. That may be the case. They may have security flaws and whatnot, but that's not the number one reason why websites got hacked. A lot of times websites got hacked because of the web scripts that are running on top of the database. People can inject code to make the web scripts do more than what they're supposed to. Okay. So that's why I kind of brought it up, because when you write web scripts, you really have to prepare for a lot of contingencies. What if someone intentionally craft the query to be something different, something that you do not expect? Can you double check that script or the query before you execute it? Okay, so there are a lot of issues that you have to think about when you do web scripting. Any questions about that part of the comment? No comments? Okay. Well, there is good money in web scripting. That's one of the area where there's a lot of demand of programmers. All right. So, getting back to our program, are there any questions about the program itself? Questions? Has this changed the mind of some of you? You don't have to raise your hand or tell me, but has this changed the mind of some of you about what you think about programming or software development? Sorry? Oh, you don't think so? Okay.
No, I said I think so.
Okay. Well, there's a lot of details. Okay, when people think about programming, you watch the movies, and people do programming and they go like that, but they don't really tell you. The movies don't depict the amount of details involved in programming. Okay, a lot of little things you have to track. If you make a small mistake, the program doesn't work anymore, or it doesn't work in certain cases, and you have to track down the problems, and so on and so forth. So programming involves a lot of tracking of details. Now, if you kind of change the setting a little bit, instead of thinking about this program from the perspective of the developer or the programmer, the person who's writing the script or writing the actual code, and switch back to the mindset of the executives of a bank. Okay, do you think the executives of a bank will express the logic like this? In other words, if the executive of a bank wants to tell somebody else and say, I want our system to be more secure and lock out attempts to hack into accounts. Okay, that's usually how they would just say it. Probably not even using those particular terms like hacking or authentication. They would use the more colloquial terms. Breach. That's a pretty big word too.
Yeah.
I think bankers use some other words like break into or something like that, because breaking into also fits the physical breaking into of a bank, so they they understand the term better than other terms. Okay, so from the banker's perspective, how do you think they would express the logic of this program or the requirements of this logic?
After a few attempts, shut it down.
After a few attempts, shut it down. Okay, so after a few attempts, shut it down. And as a programmer, when you read those statements, do you think you can understand those statements well enough to understand? Oh, so this is what you wrote. This is what you want.
Not to
You have
the
to think
extent.
more.
Yeah.
Yep.
It
You have
takes
to-
actual thought.
Because it's ambiguous. Okay. After a few attempts, lock out the account is very ambiguous.
Yeah.
Okay.
So many options.
And that's why we are, after introducing all the details of programming, we are now actually going back to this part here. Okay, we have already talked about programming functions, because we did write some programs. I will go ahead and give you an overview of languages. I do not encourage the use of flowcharting. Flowcharting is used by a lot of people. Conventionally it is the representation of logic, but it is not really suitable. It's really a bad idea to use flowcharting. I'll tell you why later on. Pseudocoding means you're not actually using real code. You're actually using what we call pseudocode to express the logic of a program.
It's like a false code, right? It's like a false code.
Yeah, it's
Pseudo means false.
Yeah, pseudo is false, and then code is program. So it's program that is only intended for human reading, but not for the machine to understand. Typical computer instructions. There's no really such thing as typical. Structured programming and techniques that we have covered. Okay, when you go back to Scratch, this is structured. The program that we did on Tuesday is structured. In fact, Scratch does not have the ability or the flexibility to let you write anything that is not structured. Okay? Because when you look at this code here, or the code that we wrote on Tuesday, there's no way you can actually mess it up and end up with what we call spaghetti code. Spaghetti code gets its name of spaghetti because when you try to follow the logic of a program, it goes like that. So it's not like regular. It's not straight or structured. This is structured. Scratch does not let you write spaghetti code whatsoever, and yet it is graphical, kind of like flowcharts. It's graphical. You cannot make syntactical mistakes, so it has the advantage of pseudocode. Because the one thing that's nice about pseudocode is you cannot make syntax errors because it's intended for human reading and not for the machine to read. But once again, using Scratch, you cannot have syntax errors because you're dragging and dropping the blocks. You cannot drop a block to where it does not belong. So therefore, you cannot make syntax errors or grammatical mistakes. So Scratch actually fits a lot of the requirements that was mentioned here, with flow charting, because it has the arrows. It indicates, the flow of the logic. You can use it for pseudocoding purposes. It's not typical computer instruction because, typically programs are all written in text, and therefore we have a lot of problems because of that. It is also structured. Okay, a construct can contain another construct because of that. Okay. And the only part that I have not mentioned is the overview of programming languages. And I can cover that, in a relatively small amount of time. And instead of doing this, I can use another tool, excuse me, called FreeMind to illustrate it. All right. Yeah, this is a really neat tool. I like it a lot. So we'll call this, programming languages, or we'll just, abbreviate it to language, which means, in this context, it's computer languages. It's not natural languages. Okay, when you look at computer programming languages, the first thing you might want to ask is, okay, why do we need a computer programming language? What do you think? To automate something, yes, but we need to tell the computer what to do. Okay, and just like if I want to tell someone else how to do something, both me and the person who's receiving the instruction, we have to share the same language because otherwise, there's no way to convey what to do. And it's the same thing here. A computer programming language is basically a protocol, a language, so that you, as a person, can instruct the computer and say, okay, I want you to do it this way, and this way. Okay? So it's just like a natural language, except it's not intended for another person, it's intended for the computer. There are two big categories of computer programming languages. Let's see here. Okay, let's go ahead and do it. There are different ways to segment computer programming languages. I'll do it by compiled versus interpreted first. Okay. Now, all right. So outside of the context of this picture, I have to kind of tell you something first before this starts to make sense. The language that we typically use for programming, which is C, C++, Java, Perl, PHP, Visual Basic, and so on and so forth, they seem to make sense to us because all of these programming languages use keywords like if, while, repeat until, and so on and so forth. So to us, it makes sense. AND means a certain thing. if if means a certain thing, while while means something. But you know what? Those words mean nothing to the computer, to the processor. Do you guys still remember from earlier chapters? The processor, the CPU, has its own language, right? In order to add two numbers, the instruction is basically a long sequence of zeros and ones. That is completely unnatural for us to remember. So that's called machine language, okay? So we can actually add another category here, which is called machine language. Now, if you can program in machine language, then you don't need interpreted or compiled languages, because you are talking in the native tongue of the processor. But very, very few people can do it with a simple 8-bit processor. No one can do it practically with a 32-bit processor. Not even the engineers at Intel can do it.
That would be
Okay.
impressive.
They can probably remember the binary bit pattern of certain instructions, but there are hundreds of instructions, of that sort. So no one can actually remember, all the hundreds of instructions like
Unless
that.
they were born and only taught that language, spoken ones.
Then they probably cannot do some of the other things that Intel requires of their engineers.
Like type on the computer.
They don't really have a need to know it.
Right. Nobody has a need to do it because of the interpreted languages and the compiled languages. So now we'll go ahead and take a look at interpreted languages. Okay. Interpreted means the translation on the fly translation. Translation. There we go. So that means when you write a program, it is written in a way that we can understand. But the translation to machine language is done on the fly, which means when you execute the same part of the program again and again, it is potentially possible that that part is translated again and again. So it's kind of redundant, and that's why the efficiency is actually lower with these interpreted languages. So I can add it into the mind map too. Okay, it is usually less efficient compared to the alternative. Less efficient in this case means two things. One, it may consume more memory, and two, it may consume more time, more processing time. But it does offer certain advantages. Okay, one of the advantages is it's usually very flexible, and also you can make quick changes, which is very important for certain types of application. Let's take a look at some examples of interpreted languages. Very typical examples, since we've just mentioned the web scripting, PHP is one. Okay, so let me use examples as one block here and then make it expanded and into the actual examples. We have PHP. PHP is almost used exclusively for web scripting. We have Perl. Perl is essentially the Swiss Army knife in scripting. Swiss, uppercase, Swiss Army knife. Visual Basic is also interpreted. Visual Basic. And I would say earlier versions, pre.NET. Are there any questions about these programming languages or why we have interpreted languages? No questions?
What does PHP stand for again? What does PHP stand for?
There are different interpretations of PHP. So I think the current interpretation, if you look up PHP, is it doesn't say how it gets its name. No? Look at wiki. It's not open source either. That's actually not entirely correct. It's personal homepage, and now it is PHP : a hypertext preprocessor, which means this is what we call a recursive definition, which means you never really figure out what PHP stands for because it says PHP is hypertext preprocessor.
Kind of like
GNU,
wine.
Wine, GNU, Lane, they are all like that. Computer science people like names like that.
Just to mess with you.
Just to mess with you, yeah. That's also why slash dot is called slash dot. You guys know what is slash dot dot? I think it's a .org. No, okay.
/dot.org.
Slash dot, yeah, that's why. It's actually spelled out as slash dot .org.
Yeah, I was thinking literal.
Yeah, it's basically geek news website. They post all the latest news on in different areas. But the reason why they picked that name slash dot is so that when you spell out the URL, which is http:// and then you say slash dot to mess around with people, right?
Yeah, you can actually do the literal.
Yep, exactly. So getting back to mind map here, compiled languages is basically the opposite of interpreted languages. So that means a lot of the points I can make here is really just the opposite. Instead of on-the-fly translation, this is a one-time pre-running translation, which basically means if you have a 500,000 line program in a compiled language, it will have to compile or translate all 500,000 lines before the program can even start running.
Makes sense.
Which may take up some time. Whereas in an interpreted language, because the translation is on the fly, if you have a 6 million line program, you know what? It doesn't take up any time if no one is running that program. When you run the program, you only have to execute, let's say, 400 of those 6 million lines. Guess what? It only has to interpret those 400 lines that you're running. The rest of the 6 million lines of code remains in text, and nothing is being done to those 6 million lines. So that's why interpreted languages have the flexibility of you can make quick changes without having to say, oh, okay, I just made a one-line change out of 6 million lines. I cannot run this program again because I have to go through the one-shot pre-running translation all over again, even though the other 5,999,999 lines were not modified. Okay, so that's why there are advantages to translation on the fly because it saves you all that time. But compiled programming languages also give you advantages because it is much more efficient compared to on-the-fly translation or interpreted languages. And that's why people when they compare C and C++ programs to, let's say, Visual Basic or some of the PHP programs, the C versions of those programs will scream, it's so much faster, 10 times, 20 times faster compared to the interpreted languages ones. That's a really big advantage.
So why is it it just works faster than the compiled than from interpreted?
Because
interpreted is more, you can make quick changes.
Right.
It's
It's a lot more efficient when you run it. In other words, one is on-the-fly translation. In other words, as you tell me how to do something, I will translate your instruction so that the processor understands what you're telling me. The other one is saying, okay, give me your 600 million lines, 6 million line program. I will translate every single line into machine code and then give the entire translation to the machine to execute it. Okay, so in the case of interpreted, if you just want to make one little change in your program, you just have to say, oh, tag, by the way, I don't want to do it this way on line 16 anymore. I want to change it to this way. I only have to restate that to the machine once. Okay, and the rest of the program, 6 million lines, I don't have to do anything until the execution of the program calls for those lines. Okay. So when you look at this list here, this is flexible. Compiled programs are not as flexible, so I will just call that not so flexible. Okay. And you also don't want to make frequent small changes to a compiled program because of that reason. Okay, so it does not handle quick changes. Okay. And let's take a look at some examples of compiled languages. Very typical, would be C++. That's a really popular compiled language. And that's really the only one that people really use, is C++. But if you want to look into some other ones, I'm trying to think of other ones. There are a lot of programming languages that are compiled, but they are not really used anymore. Ada used to be the programming language of the DoD, the Department of Defense. So all of their projects had to be written in Ada, but they had to give up that practice because Ada was not a very practical programming language. So after a lot of money put into the research and development of Ada, they eventually had to give it up. And those programs are really quite unmaintainable. Between these two, there's actually another category. It's called a hybrid. Now I call it hybrid, because it's actually halfway. Okay, it is compiled, but also runs on virtual machines. Okay, in other words, it is interpreted, but it's low-level interpretation and not high-level interpretation. Go ahead. Sorry.
Is Java under that category?
Okay, examples would include Java and Visual Basic, VB, C#, C#, is sharp here. And most of the .NET languages fall into this category. Now what it means, when I say hybrid, it is both compiled and runs on a virtual machine, means the actual code is compiled. But when it's compiled, it's not compiled to the machine code that your processor can actually understand. It compiles to the instructions of what we call a virtual processor, if you will, so that you can implement a virtual machine to interpret that code in return. And that's why it is both compiled and interpreted at the same time. It has both the advantages and the disadvantages of both types of programming languages. From a certain perspective, it doesn't have, okay, let me just add this part here. It is somewhat efficient. It is somewhat efficient because when it runs on the virtual machine, they can actually do on-the-fly compilation to compile from the virtual machine instruction to the actual machine instruction. But it's done on the fly, or they call it just-in-time, okay? JIT, just-in-time compilation or optimization. So that's why it is more efficient than a strictly interpreted language, but it's not as efficient as a compiled language. When you look at that's the efficiency part. If you look at the flexibility, it has almost the same flexibility as an interpreted language. So I would say this is almost as flexible as interpreted languages, which means you can also make quick changes. And that's why the web scripts of a lot of websites, especially the commercial ones, are written in Java. The backends are all written in Java, or ASP. ASP belongs into this category too. So if I want to extend this list a little bit, I can also include ASP, which is Active Server Page from Microsoft. Okay. I forgot one example from here. So when I look at these examples, it also contains Python. Python is the new shooting star. Some people are using Python to replace Perl as the Swiss Army knife, in the world of scripting. So that's basically a kind of a brief introduction to computer programming languages, without getting into the details of the syntax and also the tools. We are running out of time today, so don't forget you have your homework. It is assigned. It's due in a week.
How supposed to email it to you, or how supposed to?
If you scroll to the bottom part of the assignment, there's a button to upload the file.
So you're gonna just try those all of them? Or just look
Yep.
at the
Yep. I trust Scratch well enough that if you try to run any malicious code, it will stop it.
I was just wondering
Plus, if you're in this class, you probably
I learned a little bit like C and then C++. Like, is it a expanded hybrid?
The only difference is C++ adds more object-oriented programming features to plain C. Very few people write programs in plain C anymore. It's just because it's a harder language to write programs for, and you cannot leverage the advantages of object-oriented programming.
Yeah, because I've done a little bit of programming, like C++, basically had a lot of HTML and some Java. So it was interesting, but it
The
wasn't
Java
enough.
resembles C++ a lot, but if you learn one, it's easy to pick up the other.
Yeah, just some certain things are different. It's like when I got used to it.
Right. Syntactically, they're very close.
Yeah.
In terms of most concepts, they're close to.
Is that why so many of the ones for in the program history, the C+ and the Java have so many of the same?
Yeah, they